everyone, welcome back to our YouTube channel Becoming a ROS Developer. Today we've got Divyesh, who has just completed the course Linux for Robotics, and he'll be giving us a presentation on that. So first of all, we'll begin by seeing a demonstration of his code base running on the real robot, and then after that we'll get into the nitty-gritties about his project. We'll then, towards the end, finalize by asking him a couple of questions. So without further ado, I'll now hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Divyesh.
So first I'll show my project on the simulation, then I'll show it on the real road.
Okay, all good.
So this is the live obstacle about the code. So first it takes the sensor values. It takes multiple sensor values from the front left side, front right, and the right side. It, using some basic if-else conditions, it determines its direction to move. As the front was free right now, we can see that all three directions were free, so it decided to move front for a certain distance. Now you can also see in the statistics that the approximate statistics of the robot, the distance it moves, the direction, the current direction it's facing, its position in terms of coordinates, its orientation, and depth. So this code will keep running indefinitely until I close it, and it will not crash with any.
Alright.
That is the basic warning code.
Let's see if it manages to make the 10.
There's still some space left, so it decided to move.
Okay. Well, what threshold did you use?
Threshold, I just used the threshold that was given.
Okay, 0.3. Alright.
So now it should take a turn because the 0.6 threshold is not there. As none of the directions are free, it will decide whichever direction has more distance.
Okay.
So if your right had more distance compared to the left, it turned a certain amount to the right. Again, the front is not free, so it should make another turn. The front side is free.
Alright.
So it will turn right over. I could have probably increased the turn radius so that it would turn a bit more at each time it was supposed to turn.
Alright. What radius did you use for this one? Or for how long does it have to turn? Did you use a time constraint on the angular velocity?
I used the time constraint. I didn't use my own. I just used whatever was given.
Okay, alright.
So for example, from the simple robot, I had just copied the value that was there. So right now it's...
That was in the project, okay, I see.
For 1.5 seconds.
Okay.
So it has turned successfully into a free area, and now it's the statistics are updating. So till now it has moved 1.469 meters. Currently we can see all the statistics.
Okay.
That's it on the simulation. Let's see on the real again.
Sure. Okay, so
the connection I think is not established.
Can you maybe try using tailop to his keyboard?
So I'm pressing I, it should move forward, but the robot is not moving.
Okay. Okay. Disconnect and try reconnecting again.
It doesn't seem to be moving.
Still not moving.
The joystick, moving the joystick, it's not moving.
Right, I think so. All right, no worries. Wait for it to, maybe we'll try towards the end. Can you just take us through your code base so that we can see what you did and how you managed to do it?
So this is the code where I've defined all the functions that I use for the main code.
Mm-hmm.
So, there are a lot of functions to get all the scan ranges from the front, right, left, etc.
Mm-hmm.
Then there are functions to get the velocity, linear velocity, angular velocity, the minimum and maximum of the scan range that we got. A lot of functions.
Yes.
There are functions to get the odometry, position, distance, orientation, etc.
Yes.
So first I source the file so that I can use all the functions. I just print some text to this. I define the threshold and then in the while loop so that it runs forever.
Okay.
First I get the left ray range from the sensor and I store it in the LL range. I get the front left ray range, the front ray range. I also get the front right and the right. So these are the 5 ranges that I'll be using. Now I first check if the front is greater than the threshold that we set, 0.3. If it's free, then we first print that the front is free and we move front.
Mm-hmm.
Then we also check for the front left and the front right in the same way. Now here is our if conditions that make all the decisions. We check if the front is free, if the front is not free, if the front left is not free, and the front right is also not free.
Mm-hmm.
Then we check either the right or the left, which has more distance.
Okay.
Accordingly, we take a turn. So if the left range is greater than the right range, that means that there's more available distance in the left, so we take a left turn. Else we take a right turn.
Mm-hmm.
Then the other condition that can happen is if the front left is not free, the front is not free, but the front right is free.
Right.
In that case, we automatically turn to right because there's no other choice. Else the front left is not free, the front is free, and the front right is not free. So the only way we can go is front. So we calculate how much distance we can move.
Mm-hmm.
That is the range that is free minus our threshold value because that they're guaranteed.
Okay. Okay.
So we calculate the time which would be required to cover that much distance from the basic speed divided by the time.
Okay.
Distance divided by time. Distance divided by speed to get the time. So we get the time to move and we switch on the motors for that specified time.
Okay. Okay.
That's it. That's how we move forward. We till the time we calculated with a constant speed of 0. Then, for example, if the condition is that the front left is not free, but the front and the front right is free. So instead of risking by going front, we take a right turn. Then if the front left is free, the front is not free and the front right is not free, then obviously we just take a left turn because there is no other choice. Now if the front left is not free, the front is free and the front right is free, then I think I made an error here. It should have been front left is free, front is not free, and front right is free. I think I made an error.
All right, I see.
Yes. So in this case, it would have been that the front left is free, the front is not free, and the front right is free. So we have only either right or left to turn because the front is not free.
Okay.
So in that case, we again compare the values of the left and the right range, and accordingly we take a turn. So if there is more available distance in the left, it's greater, then we turn, we take a left turn, else we take a right turn. Now if the front left is free, the front is free and the front right is not free, then again instead of taking a risk by going to the front directly, we take a left turn first. That's all the conditions that there were.
Alright.
The last condition is that if all are free, then we just go front. If all the directions are free, then we just go front.
Alright.
For the statistics program, we again first source the main file with the functions, and we just simply record we take the values of the functions, store it in a variable, and we just print the variable. That's all we do.
Alright, so it's basically for giving the current data.
It's the current.
Okay, alright. Anything else you would like to speak about?
Not really. It was a fun project. I learned a lot about Bash scripting and Linux.
Okay, that's good. So let's go back to your naive obstacle avoider, right? I see there are some things that need detailing. So we have seen that every time you deal with just hang on one sec. Oh, it's okay. Every time you deal with some type of data processing, right? For example, when you compare F1 range with your threshold, right? You include the pipe and then BC and you use the ELF. Like, can you explain what that is doing? What is the purpose of that? And what happens if you do not include that? Did you hear my question?
Yes, I heard. I'm not really sure what its purpose is because I had just copy pasted it and I didn't really check what it actually does.
What it actually does. Okay, all right. Because I think it's quite important to understand what it is doing for you, right?
How the code is working.
Yes, yeah, it is important. Anyway, let's go on to some general Linux terms, right? So in general, what is the purpose of bash scripting, right? Why is it necessary in robotics, and why do we have to understand how to work with that, with bash files specifically? Yes.
Bash files are very important because when we use the shell, we can only input one command at a time. But with bash, we can create a script that contains a lot of commands. We can use conditions like if else, so that it's basically a way so that our programs are more orderly. Because in shell, you'd have to input it one at a time. But in a bash script, it's all there.
Okay.
And
true.
the shell reads it once.
All right.
It's a more orderly way of creating things.
Okay. All right. So it's more like for the management of the terminal, right? And also trying to bulk load your commands. Okay. With regards to the terminal, can you tell me how you can push processes to the background and how you can get them back?
We can use we can simply press Ctrl plus Z while a command is running to send it to the background. And to get it back to the foreground, we can
you should have two
use the
options.
FG command, I think.
Yes, yeah, that's one of them. The other one is
And to send it to the background, we can also use the BG command to send it to the background.
uh-huh.
Either control plus Z or the BG command.
All right. And have you heard about jobs?
Pardon?
Have you heard about jobs command that helps you to uh, bring processes that are in the background forward, or at least list them so that you can see? You haven't. All right. Yep. But I'm happy with FG and Control Z and BG. Okay. So thank you on that. And the other final question for me is: so let's say you want to filter your terminal, your console output, right? What is the general command that we use?
Didn't get it.
If you want to filter any form of output that you are requesting the terminal to give you, right? So let's say you want to list all the topics, or you want to list all the processes that are running, and you want to filter all of those that have got a particular prefix or a particular ordering of
we can first just type a command like psfox, and then to filter we first give a pipe, and then we write the grep command, and then whatever keyword we have.
Right.
And this grep command works with any command in Linux, so we can use it with any.
Okay. All right. Yeah, that's good. That's true. Yeah. All right. So that's it from me. Can you just see if you can try reconnecting to the robot? I think you've got a couple of minutes left.
If I try to reconnect.
Okay. It's still not moving. Okay.
The joystick is not working.
All right. Let's just try one more time.
Still not moving.
Still not moving. All right. No worries. I think I'm quite happy with what we've done so far. So let's wrap it up here, and you just hang on for me, okay? All right, everyone. This was Divyesh project, and would like to encourage all those of you who would like to come and present their projects to do so, and you can get a chance to get your certificate. So until next time, keep pushing your ROS learning. Bye bye.